In this video, I would like to introduce to you the result viewer. As you saw previously in the course, it might be useful to insert interactive tables into our overall final report. This can be done with the help of the interactive result viewer. But of course, similarly to WinGraph, Result Viewer is also a standalone program, so you can start it from SSD by clicking on this button here in the top ribbon line. Basically, the same principles are valid for WinGraph and Result Viewer, meaning that both of them can be used as an interactive graphic or can be used as a standalone program. In this video, first I'm going to show you the result viewer as a standalone program, and then later on I will show to you how to use it as an interactive list or tables, or even how you can export some information into Excel. Okay, please open the result viewer by clicking on the results button in the top ribbon line, and then hopefully result viewer will be open for you, showing the first found cross-section in the system. The report browser was primarily developed to represent the results of the cross-sections in the form of graphics, but it is also capable of plotting or printing the input and the output of the database in a table format. And it can also create very nice diagram about the results as well. Which representation type is the best? It of course depends on the situation, the model, and what we would like to show for the reviewers. So there is no concrete or exact answer to this, but I will try to show you which type of representation to use in which conditions. Maybe now I will start with the demonstration of the graphics. On the left side of the screen you will find a sidebar similarly to WinGraph. And in this sidebar at the moment we can see one document, and in the document we have one A4 paper, one page. Inside this page we have one graphic, and in this graphic we have one layer. So it is exactly the same structure as we get used to in WinGraph. Here of course you also have the possibility to insert new layers or graphics or even pages. Let me show you how it works. In Result Viewer the procedure is a bit easier. So for example, if I just right click on the last layer, I can simply select the duplicate button, and then in the graphic now I have two layers. Similarly, if I click on the graphic and choose for example duplicate, then I'm going to have two graphics in the first page. But I can also duplicate or insert new pages by selecting, for example, the duplicate from the drop-down list. A new page will be added to the document. The deletion of the layers, graphics or pages is very simple. Simply I need to select the page and hit the delete button and it's going to be deleted. Also, if I select one graphic and push the delete button, then the graphic and the coupled layers will be deleted as well. So let's get back to the original status and delete back the last layer that I had created. If you select the last layer, you also have the possibility to choose from the results or from the input if you go for the selection button. With the small arrow you can drop down the button content, and as you can see we can choose from the system values, results, or from the design. Again, if you remember, this structure is very similar to WinGraph, where we also had the system values, the results, and the design chapter for representation. First, let's open up, for example, the system values, go to the cross sections and choose, for example, the stressed points for representation. So open up the chapter and select the element name and then hit on the OK button. As you can see, the stress point that we had defined previously in the cross-section editor are presented now. We can also reach the selection by double-clicking on the layer, and here we can add multiple elements for representation with the help of the control button. For example, if I'm also willing to present the, let's say, the Z coordinate in the cross-section, then I simply need to push the control button and my left mouse button at the same time, and then hit the OK button. And now in my graphic I can see two layers, from which the first one is presenting the stress points names, and the second one is presenting the stress point coordinates. Of course, they are presented on top of each other, that's why it is very difficult to see a clearer view. But if you zoom in by using your middle mouse button, you will see that really there are two things represented at the same location. If you now click with your right mouse button and choose the zoom border option, the cross-section will be presented again with its full extent. Now I'm going back and select the second layer and simply delete it with the delete button. Now I will click once more on the layer remained, and from the drop-down list I will choose this time a single reinforcement, and with the control button I'm going to choose, for example, the layer number and hit the OK button. The reason why I did this because I wanted to demonstrate that if you select the last layer and then go to the the graphics tab or the graphics ribbon bar, then you can select and change the size of the text on the selected layer. For example, if I want to change the size of the reinforcement text, then I will simply highlight or select the text size, and I will change from 0.16 to 0.12 and then hit enter, and then really you can see in the layer the representation of the text has changed. And I believe now this graphic shows a more reasonable representation. Now if we go back to the home page, I would like to show you another way of selection of the representation. Instead of double clicking on the layer, you can also double click on the graphics and, for example, choose only the element name, and then the multi-selection will be ended, and now only the element name will be presented on one layer if I click on the OK button, and really we can see the stress point names in the screen. If you have chosen what you want to present in the selection, you can also edit the selection. If you drop down the edit selection, then a box will appear. In this case, it will show the available cross-section in the database. So when, for example, you have a warning message regarding one particular cross-section, and this cross-section is an interpolated one, you are going to see a 3-digit number cross-section. And an optimal way to find this cross-section is to open the result viewer and represent the cross-sections and choose in the edit selection the corresponding cross-section for review, and then click OK. You can also scroll back and forth between the cross-section by clicking on the previous or next, and if you do so, you will see that really the non-effective area is changing in the interpolated cross-sections as we controlled it with our variable. The content of the edit selection is always changing depending on what you are representing in the screen. Or if you want to represent the stresses in the cross-section, the edit selection will contain the available design cases or load cases for you. I will demonstrate this right away, but before that I would like to point out that as soon as you change the edit selection, the corresponding area here on the right side will change as well. So now I will select the graphic, I will right click on it and choose the duplicate option, and then from the graphics, from the second graphic, I will double click on the contained layer, and from the drop-down list I will scroll down and choose the Design chapter. There I will open up the cross sections, and there I will choose the AQB, exactly from stresses of beams AQB, and select the reinforcement steel stress and axial material stress in cross section, and then I will hit the OK button. What we can see on the screen now is we have one A4 paper which contains two graphics, and in the second graphic there is one layer that is representing a linear stress distribution of the cross section. And in this case, and this is what I wanted to demonstrate, the edit selection will contain the available load cases in which the linear stresses were assessed. For example, let's choose now the load case or design case 2105 and hit the OK button. If you remember, this load case 2105 was the load case for the ULS design check, and it was created for the max MY combination. Please also notice that since we are now presenting the linear stress distribution within the cross section, it is also possible to choose which element we would like to represent on the screen. By default, it was set to 200,017 because I have investigated that. But as you can see, you can choose any of the beam elements at the beginning or at the end point of it. And of course, the results will change accordingly. If it is not the case, then it means that you do not have any results stored from this load case in the selected beam section. Okay, now let me insert a table into the very same page. What you need to do is select the last graphic and go to the Add option, and from the drop-down list you need to select the list, and I will open up the system values chapter, also the cross-section chapter, scroll down a little bit and choose, for example, the effective cross-section values, from which I will multi-select the sectional area, the torsional inertia IT, the bending inertia IY, and the bending inertia YZ, and then click on the OK button. And what happened is, in the very same page, now we are representing two graphics plus one table, which contains the effective cross-section values of cross-section number 1. And again, if I go to the edit selection, of course, I can also represent the effective cross-section values of cross-section 2, for example. However, in this case, a multi-selection is also possible. For example, I can uncheck all the selection, or I can check all the values in the selection and then click OK. And now the table has changed, and it is presenting all the cross-section with their corresponding effective values. Okay, when you finished with the definition of your first page, then you can have an overview how it's going to look like in the report browser if you click on this Print Preview button. If you do so, then you are going to see how the created page will look like. So first we will see the stress point in the cross section, then in the next page we are going to see the linear stress distribution of the cross section, and finally a table about the effective properties of the cross section. If you now click again on the edit mode, you will be directed back to the view of the result viewer. With this information, I'm finishing this video now, and I'm going to continue the explanation of result viewer in the next one. In this video, I would like to talk and elaborate a little bit some information about the adjustment of the tables. So I will simply select the document, go to the Add button, and I will add a new page to the document, and by default it's going to present again the cross-section overview. However, now I would like to change this graphic representation into a table representation. So I'm going to the top ribbon and I'm going to select the table instead of the graphics. Now the representation has changed, but still the result viewer showing me within this page a table about the cross-section overview. Instead of the cross-section overview, I would like to represent some results of the beam elements, and therefore I'm going to double-click on the layer and choose from the results chapter the beam element subsection, and I will select the forces and, for example, the MY bending moment, and click on the OK button. Let us have a closer look at this table. In the first column, we can see and find the load case number. In the second one, the title of the load case. The next column presents the element number, the beam element number. The forthcoming column presents the distance at the beginning and at the end of the beam element. The next column presents the factor of the length of the beam element. So we can also say a relative distance of the beam element. 0 means at the beginning of the beam, 1 means at the end of the beam. Now let's select from the edit selection box one of the construction stage loads, for example, the introduction of the superstructure. So I will uncheck all the load cases, scroll down the list, and we'll search for the load case 4020, which is going to be somewhere here. Yes. So I will choose the installation of the superstructure and hit the OK button. As you can see, every beam element is 2 times in the table, because once we are presenting the results at the beginning of the beam and once at the end of the beam. As you can see, this is valid for every beam element in the table. Okay, now let me add one additional table into this page. So I will select the page, right click on it and choose Add Table. And now from the drop-down list, I will go for the system values and search for the structural elements entry. And there I will open up the structural lines chapter. And there we can see beam sections along structural lines. I will select it and click OK. Now let's investigate this table as well. So basically this table is a system value table. So we can find also in this table at column beam the number of the beam elements and also the length of the beam element. So again, we will find every beam element 2 times in this table, once with the beginning section and once with the end section of the beam element. In the first column, we will find the number of the structural line as we defined them in SOFI Plus. Then the station value. In the next column, one can see the substructural line after the meshing procedure and automatic subdivision was undertaken. And in the last 2 columns, as I mentioned, the beam element number and the sectional abscissa at the beam beginning and at the end. Now please notice that the 2 tables have common information within it. And if 2 or more tables has common information, then result viewer can join these tables together. I will demonstrate it by inserting a new table into this page. So I will right click on the page and choose the Add Table option. And in this case, I will go to the structural elements in the System Values chapter and select once more the structural lines and select the beam section along the structural line. However, now I will scroll down, open up the Results chapter, and there I will also open up the beam element subchapter, the forces, and I will select the bending moment MY entry together with my control button and my left mouse button usage. And in this way I have selected the bending moment MY from the results and also the beam sections along the structural line from the system values. And only now I will click on the OK button. And what you can see in this table is that Result Viewer was able to join these two informations or these two tables together because they had common information in them. Let's investigate this table once more. But first I will also select the same load case for representation. So I will uncheck all the selected load cases and I will select load case 4020 for representation and click OK. In this table we will find the load case number, the load case title once more, then the number of the beam elements, and then the distance from the start of the beam elements can be read. Then we will find the number of the structural lines, the station value, the substructural line, the substation values, the relative coordinates of the beam element or the relative distance along the beam element, and finally what type of internal forces we are presenting. Please notice that the Result Viewer is using two different types of colors, blue and brown. And with this, Result Viewer is indicating which information is coming from which table. So the blue ones are coming from the beam elements or beam sections along the structural line, whereas the brown ones coming from the beam elements bending moment MY table. With the help of these joint tables, it is possible to represent the results not just along on beam elements or beam element sequence, but also along structural lines. Let's suppose I would like to represent the results only along structural line number 2, so I will select some cells from the structural line numbers and I will click with my right mouse button, and from the filter options I will select the range, and here I will choose the equal and I will enter 2. So it means that the software will filter the structural lines according to their numbers, and only the structural lines with number 2 will be presented. Let's try it by clicking on the OK button. As you can see in the table, we will only find the results of structural line number 2. The number of the beam elements are also presented along structural line number 2. Please notice that structural line number 2 contains also the beam element number 200,017, which we were investigating in our design procedure, and which beam element is located roughly at the middle of the first span. However, it doesn't contain beam element number 200,035, which we already examined in the design procedure, because that element was along structural line number 3. And hence it is not incorporated in this table if we filtered it according to structural line number 2. The fact that this table is a joint table can be followed by the colors, as I mentioned, but also you can see here a second tab which represents the source tables. If you click on it, you will find the two tables that are connected or joined together, Result A and Result B, where Result A is the beam elements or beam sections along the structural lines, and Result B is the beam elements bending moment MY in load case 4020. Also, there is a possibility to review this join. If you click on this join button here, then in my other screen appeared the join result table. This small dialog box shows exactly what I have explained, namely that the two tables can be joined together because they contain common information. As you can see, in table B, the number of the beam element is the same as the number of the beam element in table A. So if two or more table has common information, then they can be joined together. However, if two or more tables doesn't have any common information, they cannot be joined together. Okay, now I will close back the join result dialog box and I will show you an alternative way to recreate this table. I will select the page and go for the add option and choose in this time the table assistant. So with the table assistant you can create the very same join table. All we need to do is follow the very easy steps. So I will choose, for example, the forces for representations, the MY bending moments, click on the next button. I will select the load case 4020 and click on the finish button. And as you can see, the very same table has been generated. We can see the load case title, the structural lines, the station values, substructural line substations, beam element number, and the MY bending moment. If we do not like the output of this table, we can format it. For example, the substructural line number or the substation number doesn't give so much information for me in this case, and therefore I would like to remove it from the table. What I can do is right click on the table or the heading of the columns, and I will select from the drop down list the columns option, and I will deselect, for example, the substructural lines. Similarly, I will do it for the substations. And maybe I'm also not interested in representing the XY values, so I will right click on the heading, select the columns and deselect XY. Unfortunately, in the drop down list at the columns, it's not possible to use a multi-selection. You need to do it one by one. Next, I would like to show you another way of representing the MY bending moments. So I will quickly duplicate the very last layer and I will double click on the copied one, and I'm going back to the system values, and instead of representing the structural elements by the structural lines, I will choose the axis submenu, and there I will select the beam sections along the axis. Then, using the control button and my mouse, left mouse button, I will also select the bending moment MY and then click on the OK button. Now the MY bending moment is being presented along the axis. In the table you can see the ID of the axis, then the station number, then the beam element number again, then the X value along the beam, the load case to be presented, and the load case title, and finally the internal force component. Please notice that this type of representation, I mean this table for example, is not possible to recreate by using the table assistant. I just want to call your attention that not necessarily every type of representation is possible with the help of the table assistant. Sometimes it is only possible to create the wanted type of table or the desired table by manual input, or I should say adjusting the settings manually. The reason why a table along an axis could be useful is that normally a user doesn't really remember the number of the beam elements in the system, and therefore it is much easier to orientate oneself along the stations of the axis. Of course, in this case we can also get rid of the unwanted columns. For example, if I want to deselect the column X, I will simply right click on it and unselect X, and now my table looks much nicer and more reasonable for documentation. We also have the possibility to go back to the definition by double clicking on the layer, and if we do so, we can select, for example, the normal force and the shear force in the local Z direction by using the control button on our keyboard and click on the OK button. And in this way we can expand our table with other internal forces such as the normal force and the shear force. If the order of the representation of the internal forces doesn't seems to be nice, then we can simply drag the column and move before or after the other one. I will also drag the shear force Vz and move in front of My bending moment. I think we can conclude this video, and I will continue with the explanation of the result viewer in the next one. In this video I would like to show you how to create the results table for the result sets. I will select the document and insert a new page, and then in this new page again we can see the standard cross-section overview. I will delete this graphic by clicking the delete button on my keyboard, and I will right click on the page and I will choose the add table option from the drop down list. Automatically result viewer shows me an option to choose from, so I will select the results chapter and within it I will choose the result sets and click on the OK button. As a result, a new table is presented with load case 31 and with its number, and above the table we can read that it is presenting the result sets named PF2, Peer Foot Support at axis 2. If we move our cursor a little bit to the top, we can find the R sets like previously we saw here the beam cross section. Now the result sets are presented in the drop down list. If I drop it down, then you will see that, for example, I can select the S1L, which is the result set at the first station on the left side. The load case to be presented remains 31, of course, but now apart from the Px, Py, Pz values, the table also presents the deflections in the global X, global Y, global Z directions. So all we need to do is just simply go for the edit selection option, uncheck all the load cases and present, for example, the superimposed cases or results of the result set. These are all stored in the load cases starting from 99,000. So I will select the first 91,000 load case and the very last one with the help of my Shift button on my keyboard. In this case, all the load cases will be selected, and then I will select the check selected option here and click on the OK button. These are all stored in the load cases starting from 99,000. Therefore, I'm going to select the first case starting with digits 99, and also I'm going to select the last load case, which is load case 99,038, but I'm going to use my Shift button on the keyboard together with my mouse to select all the load cases that I wanted, and now I will click on the check selected option. In this way, as you can see, I have selected all the load cases starting with digits 99, and I will click on the OK button. Now the table is presenting the superimposed load cases of the result sets. If I would like to present the results also of the other result sets, all I need to do is duplicate the table. So I will right click on the table and choose the duplicate option, and then go up to the result sets and select the next one, which is the S1R. Then I will duplicate the table again and choose the S2L. Then I will duplicate the table once more and select the S2R. Then I will duplicate the table once more and select the S3L, And finally, I will duplicate my table for the very last time and choose the S3R result set. If I look at now the print view, we can see how it's going to look like. So actually on one page we are going to find 1, 2, 3 result sets, and then it continues on the remaining pages. Actually in this way we can present all the results of the result set. If we go back to SSD, this is exactly how I created this table in the SSD task tree, results of the traffic loader, for example. And if we go back to result viewer and to the edit mode, I can continue with the explanation of the result viewer in the next video. In this video, I would like to show to you how to export a table from result viewer to Excel. I will close back now the pages that I don't need, for example the first one and the very last one, and I will right click on the document and add a new page. In the new page I'm going to copy over one table from the previously generated pages, namely for example the table where we represented load case 4020 and the MY bending moments within it. So I will select this table, right click on it and choose the duplicate option, and the table has been copied over. I will drag it to my newly created page, so I will use my mouse, drag it and release. And finally I will delete the graphic on my newly created page because I will not need it. And now the copied table is in my new page. Let's suppose that I would like to plot this table in the report browser, but I would like to get also an Excel export from this table. If I want to achieve this, I need to duplicate this table once more, because the first one is going to be plotted in the report browser and the second one will be exported to Excel. But how can we do that? We need to use the third tab, the table tab, and there we can select one table for output to Excel by using this button. As you can see, the table is marked with a small Excel symbol in the bottom right corner of the table. Then with the help of the next button we can set up some adjustments or settings related to this Excel file. First we need to add a name to this Excel file, for example internal forces. As the next step we also need to add a name to the worksheet within the Excel file. I will add the name LC 4020 referring to the load case that it is presenting. Rest of the default settings I can accept and click on the OK button. Now the export hasn't been executed because we are in result viewer. We need to click on the export current list in order to do that. If we click on it, then the settings dialog box will appear again. And now if we click on the OK button, the export will be executed. I also must mention that if we work with interactive result viewer file or interactive tables and lists, and we run the task in the SSD task tree, as soon as the run has been finished, the Excel file will be generated. So if in SSD, for example, we have this interactive graphic and it contains an export to Excel option, as soon as I right click on it and choose the calculate option, the Excel file will be generated. However, as we now work in the result viewer, you must click on the export current list button. Now if someone would like to review the exported Excel table, then the best way would be to go back to SSD and click on the Explorer icon, and the project folder will be open. And here we can see the internal forces Excel table is available. I just need to double click on it and open it with Excel and make it a little bit bigger. And I would like to give you one more hint here. So if you export these values to Excel because you would like to undertake the design of an element according to your taste or according to your formulas, then the best way to do that is the following workflow. You just simply need to click on this new sheet button and create a new sheet with the help of it, and then in the first cell you just need to enter the equal sign, go back to the previous sheet and select the very first A1 cell and then hit the enter button. Then all you need to do is select the very first cell in the new sheet and drag your mouse. And as you can see, we might have still values. No, there is 0 there. So this is the end of the original Excel table. And what we can do now is continue copying the lines now downwards by dragging the cells down. And we can revise a little bit the cells. For example, set the decimal numbers. Now we can continue with the copying. And in the second line, we can also revise this number and those cells a little bit to look better. And now if we select the second line and continue copying downwards, the whole table will be copied over from the original sheet. And this procedure is necessary because whenever you undertake an export from SOFiSTiK, then the original values on this sheet will be overwritten. So if you are working with formulas, the best way is to simply create a new sheet and use the revised value from the exported sheet. And that is the reason why I showed you this copying procedure, which could be a good workflow if you want to use your own formulae to design elements in your system. And let me give you one very important hint. When you're done with the copying procedure and revising the formulas and so on, do not forget to save the Excel file and close it. And the closure is very important, because otherwise SOFiSTiK is not able to rewrite the value in the original sheet upon a new export from the result viewer. So please close back with saving the project and then go back to the result viewer, and then you can undertake a new export from the result viewer whenever you need. Okay, this concludes the video about how to export a table to Excel, and now I'm going to continue the explanation of the result viewer in the next video. In this video I would like to show to you how to create diagrams in result viewer. I will close back all the pages that are not necessary for us now and simply right click on the document and add a new page. I will delete the graphic from the new page, and this is going to be the starting position. First I will show you how to create a diagram with the help of the diagram assistant. All you need to do is click on the add button and choose the diagram assistant from the drop-down list. Here we need to select the result we would like to represent, for example the MY bending moment, and then click on the next button. And then we need to select the axis. Of course, we only have one axis with the name axis, so I will just simply click on the next button once more. And we need to select the load case, which will be also the 4020 as previously was. And then I will click on the next button. Here I need to adjust some additional options if I want to. For example, whether or not I would like to show the supports and the placements along the axis, whether or not I would like to visualize the full length of the axis, and of course I want these, so I will click on the finish. In my screen on the right side you will see the diagram that I have created and represents load case 4020. On the x-axis we can see the station values, whereas on the y-axis we can see the bending moment values. the corresponding table, which we already saw when we looked at the definition of the tables and how to join them together, it's also presented now for the diagram creation. When a diagram has been created, you have the possibilities on the diagram toolbar or the diagram ribbon to adjust it, for example, add some additional legends or axes or boundary lines to it. If we go back to the home table and click on the Add button, you can see that it's also possible to create or to define a diagram manually. However, this way is quite cumbersome and sometimes the user can run into problems, so I'm suggesting you to use the diagram assistant. The reason behind is that sometimes it is not so easy to decide whether values can be presented together in a diagram or not. If it's possible, then with the help of the diagram assistant you can do that. Or I should say you can establish the diagram. Okay, this concludes this video about the creation or generation of the diagrams in the result viewer, and I'm going to continue with my explanation in the next video. In this video, I would like to show to you how to use the result viewer as an interactive task in SSD. So I will select the very last task in our project and select the post-processing group and the interactive list and graphics for insertion and click the OK button. I will double click on this interactive list and graphic, and what you can realize now is that the procedure is a little bit different from the interactive graphic, because back then when we opened the interactive graphic we were landed in a WinGraph environment. However, now when we inserted the interactive list and graphics, we remained in SSD, only the right portion of the screen changed to result viewer. So we can find our toolbar, which was previously on the left in the result viewer, now it's on the right side. However, all the other ribbons such as the result, the graphic, the page and the view remained as is in the original standalone result viewer. Now let me change a little bit the content of the page and duplicate the graphics on it. So I will right click on it and choose the duplicate, and I will redo it once more. So basically the current setting is that I'm going to have one A4 page, and in this one A4 page I'm going to have 3 graphics. Let's try and have a look at together if this is the case. So I will just simply close back this interactive list and graphic by right click on it and select the close button, and then I need to calculate it by choosing the calculate interactive list and graphics, and then I need to open its report. And then if we look at the report browser, let's see together how the output looks like. On one A4 page I'm only getting 2 pictures but not 3. So I need to go back to SSD and adjust the settings of the page. Now I'm back to SSD. I will double click on the interactive list and graphics once more, and here you can see right after the graphics the tab which is called page, and on this tab or on this ribbon bar we can control the orientation of the A4 paper, portrait, landscape. I will keep the portrait one, and we can also control the partition. And since the default setting is to split one A4 paper into 2, that's why I received 2 pictures per page. So let's try now to change the splitting into 3. Close back this interactive graphic by right click on it on the taskbar and choose the close and rerun it, and then review the reports of it. Now if I scroll down the page, yes, now as we can see we have 3 pictures per layer. Or actually I should have said 3 graphics per page. Okay, so basically that's it. That is how you can insert any interactive list and graphics. This is how I created the results of the result set from CSM or the internal forces along the axis from load case 110. So to sum up, basically you can add graphics or results of the cross-section to be incorporated in the overall report at the very end with the help of these interactive lists and graphics. That concludes this video, and I'm going to continue with the explanation of Result Viewer in the next one. In this video, similarly what we did together for WinGraph, I would like to undertake an exercise together with you and demonstrate how to do an interactive list and graphics in your SSD project. I will show you the necessary steps, and then after having reviewed or watched this video, you can simply reproduce my steps and generate the same interactive list and graphics in SSD. So the task is to create a result viewer task with 2 pictures containing the following information in one page. The first picture should show the position of the longitudinal reinforcement layers in the master cross-section number 1. The second picture should show the position of the stirrup reinforcement layer in the master cross-section number 1. Okay, now let's go back to SSD and insert a new interactive list and graphic task and try to solve the puzzle together. So I'm back to SSD, and first I will start with deleting the last interactive list and graphics what we just inserted in SSD. Therefore I will select the task and right click on it and choose the delete option. Then I will select the last task, right click on it and choose the insert task option. From the drop down list I will choose post-processing chapter, and in there the interactive list and graphics. Click OK. Then I will rename the task by right clicking on it and choose the rename option and add the name reinforcement layers to it. In the next step I will double click on it and open up the interactive list and graphic. So now we can see that in our document we have one A4 page, fine, and we can see one graphic, the first one. However, it is representing now the general overview of the cross-section number 1. So the number of the cross-section to be presented is fine. We need to represent cross-section number 1. However, we need to somehow select the reinforcement layers and show it in the cross-section. So I will double click on the cross-section overview, and from the available list I will open up the system values, the cross-sections. Then I will scroll down a little bit and search for the single reinforcement. And in the single reinforcement entry I will simply choose the layer number and click OK. And now we can really see this is layer number 1, the bottom reinforcement layer. Layer number 2 is the top reinforcement layer in a cross-section. Layer number 3 is on the left side of our cross-section. Layer number 4 is on the right side of our cross-section. And finally, layer number 5 are single reinforcement bars at the corner points. Okay, so the one graphic is inserted and adjusted in the page. Now we just need to duplicate the first graphic by right click on it and choose the duplicate option. Then after having opened the second graphic, double click on the layer in it. And now from the list I need to choose the shear sections, and in the shear section I need to choose, I believe, the layer number, and then click on the OK button. So I think now we have finished. We have one A4 paper. There is only one thing remain. I need to double check. If I go to the page, in the page tab in the top ribbon line, I would like to double check the partition, because I would like to represent 2 graphics per page. So I need to be sure that this one, the splitting 2 by 1 is selected. However, this is the case, so everything is fine. I can go back to results and right-click on the interactive reinforcement layers task with my right mouse button and choose the close option. Then the only thing I need to do is calculate the reinforcement layers task, then right-click on it and choose its report. And as you can see, we fulfilled the expectations or the description. Basically, we have one A4 paper. In the first one, we are representing the longitudinal reinforcement layers, and in the second one, the shear reinforcement layers. This concludes this video, and I'm going to continue with the explanation of the result viewer in the next one. In this video, I would like to go through another exercise for the interactive list and graphics, in which we should create an interactive result viewer task with two tables containing the following information. In Table 1, an overview of the internal forces of load case 110 along the superstructure should be presented, whereas Table 2 should look like exactly the same as Table 1, but it should be prepared as an export to Excel with an appropriate path of the file. Let's go back to SSD and start to create this interactive list and graphic task. I will select my very last task in the SSD task tree. I am right-clicking on it and choose the Insert Task. From the Insert Task dialog box, I will go down and select the interactive list and graphics and hit the OK button. I will rename the task by right-clicking on it and choose the Rename option. And I will enter the name Internal Forces along the axis, load case 110, and hit the Enter. By double-clicking on it, I will find myself in the result viewer. So in the page, I have one graphic that is representing the cross-section overview. I will double-click on the cross-section overview to change the content. Then from the available results and system values, first I will open up the system values and then the structural elements, and I will open up the chapter called Axis, and then I will select the beam sections along the axis. I am not going to click on the OK button now because I would like to also multi-select the results of the beam elements. So I will open up the results chapter, then the beam elements, and then the forces. And by using my control button on my keyboard, I will select all the internal forces that I think it's necessary, such as the normal force, the shear force in both of the local directions, the torsional bending moment, the My and the Mz bending moment. And now I will hit the OK button. The first table has been generated. Please remember that you can get rid of the unwanted columns. For example, Xi I do not need to represent, so I will go to the columns and I will deselect the XY. Also, I don't think I need the X value, so I will just select it, go to the columns and uncheck the X value. And we also need to adjust the load case, since it is now presenting the results of load case 11. So I will open up the edit selection, load case edit selection. I will uncheck all the load cases, scroll down the list a little bit, and I will choose load case 110 and hit the OK button. I believe the table looks nice now, so I can see the ID of the axis, the station values, the beam numbers, the load case number and its title, and finally all the internal forces, and all of them fit in the table. So basically table 1 is ready. Now I just need to create a new table for the Excel export. I will select the second table and go to the top table ribbon, and there I need to mark this table as output to Excel SX. Then with the help of the next icon, I need to adjust the settings to this table. I will add a file name such as internal forces loadcase 110, and I will add a title to the sheet in the Excel as exercise, for example. Then I will hit the OK button, and then I need to close the interactive list and graphic by right-click on it and select the Close option. Then in the SSD task tree, I will right-click on the interactive list and graphic task and choose the Calculate option. After having run the interactive list and graphic, I will right-click on it and choose the Reports option to see the report browser output of this task. And as you can see, really we have the internal forces in our table along the axis. We can see the stations, the load case, number and its title. So everything is according to the description. All we need to double check is whether or not the Excel table also being created. So if I go back to SSD and click on the Explorer icon, the project folder will be open. And here you can see, and we will find together the internal forces LC110. I will double click on it, and then Excel will be open. And really we can find the sheet called exercise in the Excel file. So I think we fulfilled the description of this exercise. And we also finished learning the Result Viewer program. So in the last chapter of the course, I'm going to explain to you how the report browser is working.